Up on what you're doing this week. We're going to jump into chapter 7, congruence and transformations, which is going to be directly related to chapter 6. Gentlemen, we're not off to a good start. Oh boy, we're not off to a good start. Today you have a worksheet. Tomorrow and Thursday we're going to take notes, and then you'll do an online assignment. Friday you need your math book. It's been forever since we've used your math book, so if you'll remember on Friday, I'll also give you a quick reminder too, so don't forget that. All right. Qualitative graphs. Super easy. Yep, it took these guys like 5 minutes maybe, and I saw you had it done, so I appreciate that. I got it in the grade book for you. I will tell you on Monday, we are going to do an online review. Tuesday, March 1st, 1 week from today, you have a quiz on chapter 7. Okay, it will be online. And then we will cover 7.5, 7.5, 7.6 to finish out that week. The following Monday will be a paper review, and the following Tuesday will be a paper test. So the next 2 Tuesdays, you have assessments for me. So just kind of give you the heads up on that. We have chapter 8 and chapter 9 that we're going to cover before we hit state testing at the end of April for us. Just as a reminder, if you are going to be gone in April, whether it's 1 day or whether it's 7 days, hopefully you're not going to be, please let me know ASAP so that we can arrange some of that testing stuff so it's not stressful towards when we get there. I'm not stressed about it, but I know when people are gone, it makes people stressed out, and I don't want you to be stressed out. Okay? All right, 7.1 is called congruence and transformations. Two figures are congruent. When we talked about congruence in chapter 6, we used this phrase that said same shape, same size. Very good. Same size, same shape means they are congruent. Okay, so two figures are congruent if the second can be obtained from the first by a series of what transformations can be used where they end up the same size and the same shape. Max? Rotation would work. You could spin it. Translation, sliding it, and or reflection. So if you think about chapter 6, what transformation are we missing? Dilation. Why isn't dilation up there? The whole point of dilation is it changes its size, either smaller or bigger. Therefore, it's not congruent. So we're basing things off congruence. We can use translations, reflections, rotations. When you translate a shape, a line, a triangle, a circle, whatever you want to say, the length always stays the same. The length in the original is the same size as the length in the new one. Orientation is the same. Orientation is talking about like the order of the letters. So if I have a triangle like this, it's easier to see, I think, on a triangle. ABC, if I translate it up here, if I start at A and go to the right, it's B, and go to the right, it's C, and then, you know what I'm saying? Like work my way around that triangle. Even if I slide it up here, if I start at A and work my way to the right, I still end up with ABC. That's what your orientation means, is the order staying the same. When I reflect it, the length, again, stays the same. I'm going to draw you a triangle on this. Say I had this triangle, ABC. Everybody understand what I'm talking about? If I start on A and work my way clockwise, it would go B, then C, yes? If I reflect this, if I start at A prime and go clockwise, what letter do I go to? C. Is it the same? No. So what they say here is orientation is, the word the should not be there. Orientation is reversed. Wow, I wrote reserved. Reversed. So the order, the smooth order is the opposite now. On a rotation, same thing, same size, same shape. Your length is the same. If I draw that same ABC triangle, if I rotate it to look like this, and I start at A and I work my way clockwise, where does it go to? Then, so does that change? On a rotation, orientation is the same. Orientation is the same. So length never changes. The length, the width, the height, which we're not really dealing with height, but your dimensions don't change. The order of your letters on a reflection are going to be different. And that's when we talked about labeling is so, so, so important. Okay, so what are they going to ask us today, Miss Hoff? So the question they're going to pose to you is, determine if these two figures are congruent by using transformations. If you can say this translation, this rotation, this reflection will make them line up, that's proving congruence. If they're going to end up matching up right on top of one another, you know that they're the same size and shape. So this one says, two triangles are congruent because a blank followed by a blank will map triangle XYZ onto RST. Now these are important because it's saying XYZ onto RST. We're starting here. So I can prove these two triangles are congruent because a blank followed by a blank. Who wants to fill in those blanks for me? If I start with XYZ, what would I have to do to it to get it to map onto RST? Max? Okay, so you would translate so that Z and T are overlapping. And rotate it. Okay, so he says translate, or translation, followed by a rotation will map them. Hey, Taylor, what did you say? When he said translation, what did you say? He said, what if I rotate it? Then what would you have to do? Then translate it. Does it matter if you translate then rotate versus rotate then translate? No, you're going to wind up in the same spot. Okay, and I even like Max was even more specific than what I wrote up there. He said if you translate Z to match up with T and then a 90 degrees, which direction? Clockwise, they would match up. Okay, now Taylor could write down, I'm going to rotate, then I'm going to translate, and he's still going to be correct. So just because you don't do it in the same order, you're okay. It's like having all multiplication, right? Doesn't matter if you take 2 times 3 or 3 times 6. As long as you multiply all of them, you're good. So how about this one? Determine if the two figures are congruent by using transformations. The two quadrilaterals are blank because what I look at is, could I rotate, reflect, or translate to get them to match up? You could reflect over what? Kind of like the Y, and I usually draw that in there. And I would call it almost my Y-axis too because it's vertical like that, right? So if I reflected it, would they match up? Okay, so are they congruent? So the two quadrilaterals are congruent. Nope, or rotate. Because this is like pointed out. So like, yeah, it would have to be your reflection. Because a reflection over line Y would map one quad onto the other quad. And I'm using quad as quadrilateral shorthand, and yes, you can too. They are congruent because of a reflection over line Y, and I'm even going to label that a Y, so I remember that, would map one quad onto the other quad. Did I answer your question? Yep. Now, you guys have already kind of answered the question I'm about to talk about here, but translations, you probably want to give me some type of arrow to show what you're going to match up, right? Reflections, draw the line that you want it to reflect over. And then Max was really good about telling us degrees and direction on rotations. All right, flip it over. Example 2, do this one on your own. Determine if the two figures are congruent by using transformation. The two triangles are blank because, fill this one in on your own. Can you map one onto the other using transformations? What are your thoughts? Not congruent? Why? Yeah. So like it's hard because you want to say they're not the same shape. Well, they're both triangles, but they're not the same triangle, right? So no matter how far you translate, how far you reflect, it can't change the shape of that triangle. So therefore, they are not congruent. The two triangles are not congruent. Whoopsies. Because transformations will not map one onto the other. The whole purpose of congruence and not congruent is whether those transformations map one onto the other. So now they have us look at like, where would this come into real life? Like, how could I ever use this idea of transformations in something in the real world? Well, a logo. What transformations could be used if the letter W is the pre-image? That's important. And M is the image of the logo shown. Are the two figures congruent? And explain. Remember, pre-image means it's your original. Isaac, what are your thoughts?
You could translate it and then rotate it.
Okay, when you translate, what would you translate to try to match up? But like what part? Like point on yours. Like
this.
Okay. So he's saying like if I took this corner, whoops, maybe I should use a different color. This corner right here, and I translated it down. Does that make sense? Then you said rotate it how far?
100.
Ooh, how come Max had to tell us clockwise, but you didn't have to tell me clockwise? Is the same, right? Whether you go 180 clockwise or 180 counterclockwise. Now, if you say 90, do you have to say which direction? Yes. Or 270? Absolutely. Okay, so are the two figures congruent? Yes. Yes, they are congruent. Translating W down, then rotating it 180 degrees would map it onto the M. Yes, they are congruent. Translating the W down, then rotating it 180 degrees would map it onto the M. Would map it onto the M. Okay, on your own, read through number 4, write me your full explanation, and then I'm going to ask for somebody's answer. I want a sentence written there. Okay? Answer all the questions in that, please. Because it's Tuesday. 2/22/22 on a Tuesday.
But it's still Tuesday.
It is, but I decided to do Tuesday.
Did you make that shirt? How?
Fancy.
I do like a language and like
Do this and we'll talk about it later.
Grassy. What's that mean? Grassy.
Never heard that word before. What transformations could be used if the letter Z is the pre-image and N is the image in the design shown? Are the two figures congruent? Explain. Guys, this is not going well day one. Somebody I haven't heard from today. If Z is the preimage and N is the image, are the two figures congruent? Explain. Micah?
So, yes, they're congruent. Translating Z and rotating 90 degrees, Z 90 degrees counterclockwise.
Perfect. And I would, in your drawing of some type, I'm guessing you wanted to like translate this down here to match up. Okay, so yes, they are congruent. A translation and a 90-degree, which direction did you say? Counterclockwise, very good. Rotation would map Z onto N, not M, N. So I know it's always strange to write sentences in math class, but really you're just writing out your thought on there, okay? Now, would you have to use 90 degrees counterclockwise? What else could you say? 270 clockwise, technically. If you said 90 clockwise, you're going to lose points, though. Yeah, the N would match there, but they tell you you have to start with the Z. Okay, so just be really careful there. Problems 1 through 6, they ask you to determine if they're congruent. If there's a translation, draw me an arrow. If there's a rotation, tell me my degrees. If it's a reflection, draw the line. Okay, write some sentences. And then 7 and 8 are very much like the last two we just did. I know this is not going to take you the whole hour. When you are done, keep this. We'll go over it tomorrow and then find something to work on.